Hi, here's the problem for today. So yeah, it's from the most recent contest, Silver US Open, and it's called Maze Tacto. So yeah, the problem statement is Bessie is playing this game, and it's like tic-tac-toe, but not really. And she can put M's and O's on a 3x3 grid. And when you like spell MOO horizontally, vertically, or diagonally, then you win. So yeah, in the input, they're going to have MIJ or OIJ, and IJ represents where the M or the O is going to be placed in the tic-tac-toe thing. 1, 2, 3, 1, 2, 3. So it could be in any of these 9 positions. And then the context of this is we have a square maze, which is just a grid of n times n cells, and n is at most 25, so it's pretty small. And we have these hay bales that block Bessie from going onto certain cells, so she can only move through cells that like look like this, but not like these ones. And yeah, in this maze, there's going to be like these strings or characters that tell her how to put the characters onto the tic-tac-toe board. And also, in this case, she has no opponent, so basically she's just playing by herself. And when she gets MOO, then she wins and she's done. Yeah, so it says here that once she wins, she stops. And we want to find the number of distinct winning boards that she can get by moving through the grid. Yeah, the rest of this is just input and output. So we see that because like MIJ and OIJ each take up 3 spaces, they just make everything like it's a 3n by, or sorry, not 3n by 3n, n by 3n grid, where each 1 by 3 corresponds to 1 place that you can go to. Okay, so first thing we're going to do is, because the input is a little bit different than, I don't know, normal, to process it, we're going to basically go from 0 to n minus 1 for the row, and then 0 to n minus 1 for the column. And then we're inputting 3 characters at a time. So instead of just 1, we're going to have 3 characters and we input them all. And then after this, we can store this either as an n by n array of strings, or we can just do n by 3 of characters, where like I, J, or sorry, the array, and then ij, and then 0, 1, and 2 correspond to one place. Hopefully that makes sense. But this is just to deal with the fact that they're not like just straight n by n, since there's 3 of each like unit. Okay, so this is not too hard. Also, as we're going through it, we want to find where Bessie starts from the BBB. Okay, so now onto the actual part of the problem that we have to like think about what to do. So we have these different choices of how to go around the grid, and because n is pretty small, intuitively it makes sense that we probably should be able to go through all the different possibilities or all the different states using some like graph traversal algorithm. So we're going to use DFS. I believe that BFS should work too, but DFS is generally easier to implement. But yeah, so basically what you get out of this is that we're going to go through all the different possibilities, and we have to figure out what the states that we're traversing or like going in between are. So we know that there's kind of two different pieces of information that we need to keep track of. So the first one is we are traversing the maze itself, which is the n by n grid. And yeah, that's basically, we can just use like I and j to keep track of which location we are in this grid over here. And the second piece of information that we have is the tic-tac-toe board, which is what determines like when we stop and what is a winning position for Bessie. So for this one, we're going to later need a function that returns a Boolean, and it tells you whether Bessie has won. For this one, we need to figure out some way to represent this as a state, because a tic-tac-toe board is like a 3 by 3, but there's all these different possibilities for each cell. So for this, the first step, or the first piece of information, we just have ij, which is relatively simple. But for this one, we need to think of something else. And the way we do this is, we know that there's 3 different possibilities for the value or like how a cell looks in this board. Either there's nothing, nothing, there's an M, or there's an O in it. Which means that since there's 9 spots here, we have 3 to the 9th different possibilities, or like states, for the tic-tac-toe board. And this is equal to about 20,000. For this one, I and j each have at most 25 possibilities, so 25 squared, which is 625. So overall, this should be about, so 625 times 19683 is about 1.2 times 10 to the 7th. But we're not going to go through all of these states. And the point of the DFS is to see which of these states that we can go to. So yeah, once we go to a state specified by I and J, and then also the 9 different values in this board, we have to figure out if Bessie has 1. And this is relatively easy. It might be a little bit tedious, but you just go through every single horizontal or vertical thing with 3 spaces. And there should be, I think, 8 of them. 3 rows, 3 columns, and then 2 diagonals. But yeah, and then you can just check if they spell out MOO or OOM. And then this is basically the big idea of this problem. It's not too hard, I think. You just have to realize that you have to combine these 2 different information points, because otherwise you don't have the whole picture of what place you're at in the whole process, if that makes sense. So yeah, one last thing is in order to actually traverse the DFS, or in this case traverse the maze, because once we go to a spot in the maze, we see what the position is calling for. So it could be place something, nothing, or you can't go here. But if we get to a position and we need to go to a new position, they tell us that we have 4 different choices: north, east, south, or west. And one way that you can go through these different choices without just writing them all out is if we consider a 2x2 array, or sorry, a 2D array. This is a pretty common trick. So if you let this be the x and this be the y direction, we have 2 different arrays of size 4 that are differences in x and differences in y that we're going to take. So what this means is this is usually going to be the same for any problem that you encounter, the values of these, because they represent going in these 4 directions. So basically, if we increase the x by 1, we're going this way 1, and nothing happens to the y. So this is the first direction, or the 0th direction. If we don't change the x and we increase the y by 1, it would be like this. So this is index 1, and then same thing, negative x, and nothing happens to y. So this is the second one, and this one's the third one. So yeah, if we're at some position x, y currently, then we can just loop through the 4 different values or indices, and the new x is going to be our old x plus the difference in x, and the new y is our current y plus the difference in y. And then you can do DFS on the new x and the new y, and then the tic-tac-toe board. Yeah, so this is if you want to go in these 4 directions. There's also arrays where if you want to go in these 8 directions. But I think these are pretty intuitive and you can figure them out by yourself. it's like not too hard to do that once you understand how this one works. So yeah, that's like a kind of common trick that people use, because otherwise they would have to like write out 4 different DFSs with all the different values, which is kind of a lot of work. Yeah, that's pretty much it. Basically, we're going through and using DFS to like traverse or track all of the different states. And then if we use this function and check all of the rows, columns, and diagonals, we can keep track of all the winning positions while we're going through in the DFS. And we want to make sure that our states include both where we are in the maze and what the tic-tac-toe board looks like. Yeah, that's pretty much it for this problem. So I hope that helped.